You know what's strange about the Venus flytrap? It sits there, doesn't move, just sits. And then it does, fast enough that you actually flinch if you're watching it happen for the first time, which feels wrong somehow. Plants don't do that. They grow slowly. They bend toward light over hours, days. They don't snap shut like they're annoyed. But this one does. And honestly, it kind of looks annoyed. The thing is, that speed costs something. A lot, actually, because to move that fast, the trap has to stay ready. Preloaded. Like a mousetrap that's already set, except the mousetrap is also the thing that has to digest whatever it catches. Which is a weird job description for a leaf. Most of the time, nothing walks into it, so it's just waiting. Burning energy to stay ready for an event that might not happen today. Or this week. Just sitting there, tense, like someone expecting a text that never comes. You'd think that would be a bad strategy. It isn't. Because when something does land, a fly, a spider, something small enough to bother with, the trap doesn't rely on reflexes. It's already primed. The trigger hairs inside, there's usually 6 of them. They're not measuring pressure. They're counting touches. 1 touch, nothing happens. The trap stays open. It's not that stupid. 2 touches within about 20 seconds, that's when it moves. And this is where it gets specific. Because the plant isn't reacting to weight or size, it's reacting to sequence, which means it's filtering out rain, wind, debris, a leaf that fell on it, anything that would touch once and stop. It's only interested in things that move deliberately, things that are alive, things worth the effort. The speed comes from the leaf suddenly reversing its curve. It was bowed outward, then it bows inward. The cells on the outer surface, they don't shrink. They just lose water pressure faster than the inner cells can compensate. So the whole structure flips. Takes about 1/10 of a second. You probably wouldn't see the motion clearly if you blinked. Which is absurd for a plant. Now here's the part that shouldn't work. Once it's closed, the trap isn't sealed. There are gaps along the edges. Little teeth that interlock, but not tightly. You can see through them if you look closely. So small insects? They could escape. And some do. The plant doesn't care. Because if the thing inside is too small to bother digesting, it'll slip out through the gaps, and the trap will reopen in about 12 hours. No energy wasted on something that wouldn't have been worth it anyway. It's like a size filter that works after you catch the thing, which seems backwards, but apparently it's fine. But if the insect stays inside and keeps moving, keeps struggling, that triggers the next phase. The trap seals completely. The gaps close, and the leaf starts producing digestive enzymes. At which point, it's over. It takes days, sometimes a week. The whole time the trap stays shut, glued tight around whatever's inside, dissolving it slowly. Extracting nitrogen, phosphorus, things the soil around it doesn't really provide. Because the Venus flytrap grows in bogs. Wet, acidic, nutrient-poor soil. The kind of place where most plants would just give up. So this one just stopped relying on the soil. It catches what it needs instead. Decided to become a tiny carnivore with no mouth and no brain. And it works. After it's done digesting, the trap opens again. The exoskeleton, whatever's left, just falls out or gets blown away. The trap resets, ready to go again. It can do this maybe 3-4 times before that particular leaf dies. Which sounds inefficient, but the plant keeps growing new traps while the old ones are still working. So there's always a few active at once, staggered, overlapping. The whole system runs on a kind of patient opportunism. And honestly, it's been running the same way for a very long time. You also wouldn't think this would survive winter, but it does. The plant dies back to a small rosette near the ground when it gets cold. Stops making traps entirely, just waits. The roots don't freeze because the bog insulates them, holds just enough heat that the core stays viable. Spring comes and it starts over. Same design, same triggers, same slightly unhinged approach to being a plant. Nothing about it needed to get more complex. There's a version of this plant that exists only in a tiny region of North and South Carolina. That's it. Nowhere else, naturally. It didn't spread. Didn't adapt to forests or deserts or anywhere with better soil. It stayed in the bogs. Because the mechanism worked well enough that there was no reason to leave. And that's the thing about evolutionary solutions. They don't have to be perfect. They don't have to outcompete every other strategy. They just have to not fail often enough to disappear. This one stuck around because it solved a specific problem in a specific place, and nothing about that place changed enough to break the solution. You'd think something this specialized would be fragile. It's not really. It just doesn't work anywhere else. Which is different. The design holds. It's been holding for however long this has been around. Thousands of years, probably more. But only here. Only in places that stayed wet and poor and acidic enough that the usual rules didn't apply. That's not fragility. That's just a plant that committed to one very strange idea and never looked back.